this is not only a really cool piece of technology, it's something that you can customize and bring to life yourself.
Imagine a world where like lots of devices can be connected. Everything is just interacted so seamlessly through people's voices. I think that's the future. Well, I can't wait to actually like interact with all the little everyday objects like a real living thing, if we put it that way. We are moving in a direction where AI is becoming more multimodal, which means that we not only process visual information, but also like audio information so that it can like everything can be even more intelligent.
Welcome, everyone, to the ConvoAI World Podcast, where we interview the leaders pushing the voice AI space forward. Today, I'm very proud and excited to have Diana Zhu from RiseLink with me today. Welcome, Diana.
Thanks so much. Yes.
So, Diana, before we really dive into the tech piece of it, one of the things that we really like to talk about is like the origin things. So please take me back. Tell us the origin story. What was the problem that the company was really trying to solve from the beginning?
Yeah. So all started 20 years ago with the founder, Dr. Pengfei Zhang. He was the pioneer of a Wi-Fi dual bandwidth, fully integrated Wi-Fi chip. He invented this chip, and that was a historic moment in wireless connectivity chips. And then he later found a company in Silicon Valley and successfully sold it. 2005, he decided to start Beacon Corporation, which then had been around for 20 plus years, I think over 1,200 plus patterns. And we think it's time that the US builders also have access to the super low power, highly intelligent edge AI chips that we produce. And hence this year we started our US office so that we can make ourselves more accessible for builders and intelligent on-edge devices.
Super exciting. And you guys have an awesome SDK and developer platform. Like, really excited for people to experience that. Yeah, excited for it. In terms of your own path, like, you've had a really interesting path, right? From Harvard to Yale. What led you to the world of AI and chips and wireless technologies?
Yeah, it was kind of magical. A little bit about me. I started off in applied math at Harvard. And what I was most interested in is applying research to real world applications. So I first spent a year in finance in New York developing algorithms for foreign exchange. And then I decided it was more interested in healthcare applications of economics. That's more policy oriented to actually improve people's lives. So I started my PhD at Yale studying, questions like how do we leverage AI and machine learning to match patients to the right doctors, and also what kind of drugs work best for like people have all different characteristics. So the same drug may affect different people differently. So developed an algorithm to decide that, and was very fortunate, received funding to bring one of my research projects to life as a startup after a PhD that focuses on patient provider matching. So bringing technology and latest research to real application has always been a passion of me throughout. And the story to wireless, actually, it started planting seed very early on when Dr. Zhang showed me the BK7258 dev board. And back then I was still working on my health tech company. But instantly I was like, wow, what if like my toys, like my little horse from Jellycat can finally talk? Because that's a dream growing up as a child. I'm like, I always give all these personalities and have these virtual, like not real conversations with my toys. But it seems like with all the AI technology now, this is totally something that's possible. So like that started the itch in me where I was like, oh my gosh, sometimes I probably need to make the transition to really dive into this world. So when the opportunity came up to lead the US office here, it was a pretty quick decision to start jumping into this new world. And yeah, it's been so rewarding just learning with the builders in US who are building really cool applications. And we bring them the ecosystem, the place for the platform for them to really achieve very cool like applications that are intelligent and connected to the cloud.
Oh, that's super cool. And you brought up earlier that RiseLink has been around, global company. And this is, as you said, you're here now leading the US office and opening up kind of these US operations. So so many like US developers are just kind of like starting to discover RiseLink. And I think you hit upon it really interestingly, like the area that the company is really like trying to push forward is this connectivity, this like smart device,
Yeah.
right? Like that's the message you want developers to hear. This is not only a really cool piece of technology, it's something that you can customize and bring to life yourself.
Yeah, exactly. And want to like the message that we want US developers to hear is that we understand that time to market is extremely important. And just being in hardware the last year made me realize it's actually like I came from the software background. Like on top software, like making hardware work is just so difficult because you also have the manufacturing piece. You need to make sure all the connectivity, like all the power is optimized. There's so many other concerns on top of software that you need to take into consideration. And we want to provide the most support to developers here, not only in terms of the hardware developing, making it easy to develop on our chips, but also the software support to make it we have like the full engineering support. If you have a cool idea, we want to work with you in order to make that a reality.
So cool. Supporting the developers like huge for the community. And you bring up a very interesting topic around the lift it takes to do hardware, right? And RiseLink chips are known for like their really ultra low power consumption. And how did your team kind of hit that? Like that's something that's worth like pointing out. The power consumption is very important for hardware.
Yeah, exactly. So that's actually something that we're really proud of and devoted a lot of R&D resources into. So this is kind of like a world record level of like achieving 50 milliamp in Wi-Fi keep alive. And then really it comes down to really aggressively power like saving at every level. For example, we developed the hardware, the custom wireless radio so that it can hear, it can optimize how the chip hears signals and still wake up while not consuming a ton of power. And then also really gate where power is sent to on the chip. So when some peripherals are needed, when some like the AI processor isn't needed, we just completely gate away the power so that it's not even used in those parts. And also optimizing on the firmware level with algorithm, how do we like what's the scheduling for the best time to listen for signal from the router. And I'm definitely not like a technical person super deep in the semiconductor industry yet, but yeah, I know this is something our team is really proud of and they have devoted this energy thinking about this problem.
I mean, it's huge because that's just, it adds to the lifetime of the device
Right.
that's in people's hands, right? Like the longer
Yeah.
someone can have it in their hands, the closer of a connection they can have with it,
Exactly.
right?
Exactly. And think about all the wearables, like for a healthcare device, for example, like one charge you want it to last for days. And then also the smart door locks, you don't want to always want to change battery, etc. So it's really important. And even for the toys, like we don't want the toy to have to always be charging, but you want to maximize the time you're interacting with these devices. And Wi-Fi camera, IP camera also. So yeah, for all the devices, like power is always one of the top concerns.
Completely makes sense. And aside from power, one of the other big concerns is performance, but balanced with efficiency, right? So these chips, from my understanding, are really designed to kind of do that really difficult
Yeah,
balancing act,
yeah,
right?
exactly.
And so could you tell us a little bit more about how you get the AI to run like on the edge like that?
Yeah, so you made a really good point. When we are using a lot of compute power, it automatically means that we need to use more power to support that processing. I guess one way we're trying to solve it, for example, with our latest edge AI chip, BK7259, is that we architect the chip with a dual core kind of layout, which means that when you're processing everyday, more like easier kind of tasks, we use a core that's it's called M52 from ARM that uses less processing, less power. But once you switch to something that requires more power, more processing, we switch to a different core to process it. It's called M55 Cortex. And we also have NPU on the chip as well, which means that it can accelerate the machine learning and AI processing speed for things. And so like with this dual core mode, you can see like when you're doing mundane tasks, then we just allocate power to one type of the core. so that it doesn't consume a lot of power. And then when it's not when it's processing needs more processing power, then we switch to another one of the cores to optimize.
Sorry, I'm just like blown away by the thought that probably has gone into this, right? Like it's a
Right.
multi-core architecture that has thresholding, right? So it
Yeah,
understands, okay,
exactly.
here we're going to use this core, but then we're going to dynamically switch over here.
Yeah. And on top of that, there's like an NPU that accelerates AI and machine learning algorithms when needed. And they wake up intelligently when these like different demands arise. It goes beyond me as well.
That's wild. I was just going to ask, did I hear you right? Did you say there's an NPU
Yes, NPU.
on the board? and that's on the BK7259,
Yes,
right?
that's
Okay.
and like if we're talking more about BK7259, that incorporates more edge intelligence, which means you can do a lot more things on the edge without sending data to the cloud. So what that means for builders is that now you can run like small language models on the edge so that your toy can talk to you without having to wait for the cloud large language models to respond. And also there's like it can recognize your face, recognize your voice, and understand voice commands locally without sending anything to the cloud.
So it could do like the voice fingerprint, right? Because that's
Yeah,
an NPU process, and then
right.
store that data locally. So it does
Exactly.
the animal. Oh, so it offloads those little like those pain points. Like that would be
Yeah.
so painful if you had to wait for that, right? But
Yes.
because it happens on device, it feels probably like
Yeah,
frictionless.
exactly. Exactly.
Really now, like because voice is becoming such a dominant interface with these devices, how is RiseLink positioning itself at the intersection of hardware and conversational AI? I know part of that is our partnership with Agora, but I guess like what else are you guys doing?
Yeah, so we are sitting in a very interesting nexus of things because we build a hardware foundation to enable devices to be voice ready. And we want to be the go to voice device for developers when they're making new things. So, examples are we design our socks with features like integrated audio ADCs so that it can connect to microphones very easily, can and enough on chip horsepower to enable the chip to wake up and also connect to the large language model in the cloud or do edge processing. On top of that, we also have on-device wake word detection and noise suppression, which for the chip, when someone is saying, "Hey, Agora," "Hey, buddy," like it can be named anything, the chip will like hear for the signal and in other times just stay very put and also have the super low Wi-Fi keep alive current. And as it hears words from the person interacting with it, it suppresses background noise so that we can hear better when interacting with the user. And all these are built into the chip so that the user doesn't have to worry about it. Yeah. And what I also like to mention is the partnership with Agora, of course, because we understand for people building chips, it's the software part that's also incredibly important. So like being able to partner with amazing company like Agora allows even lower, ultra low latency when people are interacting with the device so that it feels more like a real time conversation. And also we support like barge in so that people can intervene like and talk over the device when it's talking so that people don't feel like, oh, I'm just talking to a robot and I have to wait for it to finish before I ask the next question.
It has that human feeling of conversation where it's
Exactly.
very like dialogue driven, and you can
Right.
interrupt the person, right?
Right. Right.
No, that's
Exactly.
super cool. And thank you for bringing up Agora. Like we're excited for this partnership. It's been really cool to work with your team on this, and the
Thanks.
ability to bring voice to such like a small device, right? Like I have one here. It's tiny.
Yeah.
Like, and I think this whole bottom piece is like the speaker. Like the
Yeah.
board itself is this, right? That's super cool.
Yes.
It's such a small form factor.
Exactly. And you can also, when you're making different devices, you can also disassemble it and assemble it so that different electronic parts fall in different pieces. And actually, right now, I know I'm learning a lot more about hardware and also computational AI because I'm building my passion project. That's a voice device for early childhood development, a toy that can interact with children, introduce some words, and through interactive stories, very much dialogue driven because language, I guess, is like just the natural way people are interacting with the world. So building that language component into intelligent devices is just a trend that we're seeing over time.
For sure. And I mean, it's the most frictionless way to interact with a device, right? I mean, when I'm building demos, my kids come in and they see me talking to the computer and they laugh, but they also talk to it, you know?
Yeah.
They'll jump in and it just makes you realize like it's that simple. There's no
Yeah.
typing. You don't need to know how to read. It's the most natural way of communication. It's so
Right,
cool.
right. And now imagine a world where like lots of devices can be connected. So like for example, I was just talking to a company that uses our chips to build connected and intelligent two-wheelers. So imagine an e-bike that can now hear voice prompts and just guide you and navigate you to places. So that will be just like fantastic because then I don't have to use my phone to navigate me and put that voice on. And instead everything is just interacted so seamlessly through people's voices.
That's so interesting. I wonder, does it connect to your phone so that your phone
Yeah,
can
I think
stay in the
so.
pocket, right? Like it can. Yeah, that's super cool. And so you're saying you're seeing this moving not only into toys and wearables, but like connected devices in general. So like everything's going to be able to see and hear and interact at this like natural level. You're not going to have to like, let me learn what's that code that I need to push in or combination of buttons, right, to get this to work.
Exactly.
That's so cool. And at the embedded chip level, is that all with this one chip, like the BK7? Like this is the powerhouse. It can kind of go anywhere, do anything at that level. That's so cool.
Yes, we have a series of our company's chips are like generally divided into three categories. It's BK7259, which enables a lot of the edge AI applications. So you can run vision models locally, and like language models locally. Models up to a few 100,000 parameters, they can all be run locally now instead of connecting it through cloud. So we also have other categories like the BK7258, which is a dev board that you just showed that carries this chip. So that's a multimedia SoC, which means that it can connect to audio, video very easily, and it also can receive information. There's a microphone connection very easily accessible to developers. And there's the connectivity. Outside of the multimedia chips, there's connectivity chips, which allows for Wi-Fi, Bluetooth connectivity very easily at ultra low power. So one interesting application for the connectivity chips that I've been seeing is that as the I guess AGI is coming, there's a lot more power need at the infrastructure level. So we're seeing now our chips like the BK7239 series being used in terms of these like mesh Wi-Fi network to support these power plants.
Super interesting. So they connect to the mesh network and then can intelligently kind of communicate between.
Yeah, exactly. It can support up to like 250 plus devices to allow them to talk to each other, and also report back if there are problems.
That's super cool. So you'd have like one centralized device that can communicate with all of them, get the status, aggregate that data.
Right.
Because if you think about that, that's a lot of data, right? Like,
Exactly. 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 And
uh,
it's interesting because for the like on one side we're seeing all the connectivity chips, but on the other side we are also moving in a direction where AI is becoming more multimodal, which means that we not only process visual information but also like audio information so that it can like everything can be even more intelligent. So like I can recognize your face, but also hear like interact with you in terms of like audio very intelligently and also remember things about the user that I'm interacting with.
interesting, like onboard memory of
Yeah,
the previous interactions. So you can kind of
right.
ask about the last time we spoke and the
Yeah,
last thing we did.
exactly.
That's huge for like auditing, for even just like personal use, like being able to recall what you did previously without having to sit there and take detailed notes.
Yeah, exactly. And then this is pretty big. So in like toys that can keep us company, like the company that we're mutually supporting, Fuzozo, I think that's a huge. Like if a true friend will remember shared moments with us, and we want the like I guess the virtual friend that we're building here, the smart toys, to also be like that. And then I think memory is a huge part of that. And then in the personal passion project that I'm building with the smart toys for early childhood learning, there's also the memory piece that enables adaptive learning. which means that like I'll remember which words the kid has learned and then which kind of scenarios or what kind of stories they like the most, so that I'll tell more stories in that direction. So it's faster for them to learn. And then if they learn words really fast, then I can boost up the speed of learning and pumping new information to them. So yeah, a lot of areas to explore.
Oh, that's super cool because like I've built a voice AI agent that I let my kids play with, right? Very, very guardrailed. But piece is like one of the things that they constantly have to remind it is like, hey, I like this kind of stuff or I like that kind of stuff because it doesn't have built-in memory. But if that could happen on device, it's huge.
For
So they're
sure.
not like working their way to where they want to go. They kind of start where they want to go and move forward. So you talked a lot about on device, which kind of covers a lot on the privacy side of it, right?
Yeah.
And in terms of moving from like on device to the cloud, there's going to be obviously for developers a way that they can keep stuff on device, choose what goes up to the cloud, right? Like that's programmable within
Yeah,
in the stack.
for
So
sure.
how do you balance kind of like the latency on that across the edge?
Yeah, so maybe it'll be helpful to just walk through like the normal process of like what happens when we want to run, for example, large language model in the cloud while keeping some stuff on the edge, and what happens on the edge versus in the cloud. So let's just take the BK7258 dev board that you showed just now. Um, like what happens is like when there's a wake word, like here Agora, here in Armino, it hears it in the Wi-Fi keep alive mode, and then it does local processing. So then it tries to filter out the noise that it hears, the background noise, and keeps your voice as the thing that it wants to take information from. And then locally, it does audio processing so that it translates the audio to text. And if the audio is too complicated, sometimes then we will make a decision to compress the audio locally and then securely send it to a nearby cloud location so that it can be processed over the cloud. And then it can connect to the LM models, which then sends a response back. It then on the device, there's the TTS, which is the text to speech happening, then the user hears the voice back to like the information provided by the LM model in the cloud. And to reduce latency, there's lots of chip kind on the device kind of things that needs to happen. For example, how do we get rid of background noise so that it's most clear what message we're delivering to the device? And then also, how do we most efficiently decide which information is sent to the cloud so that it can reduce the latency the most?
Okay, that makes sense. And it's really a lot of that is programmable on the board in terms of
Totally.
that's super cool. And it totally makes sense having so much of it happen really on the edge on that board. You're just doing what you absolutely need to. So only incurring costs, I guess. You know,
Yeah.
when you think about from a developer perspective, you're only incurring those API costs
Yeah.
when it's absolutely kind of critical to close the gap.
Right, exactly. And then with the BK7259, for example, we are delegating even more stuff on the edge because the processing power is bigger. So there's more stuff that can be processed on the edge, even like with the smaller language models. That's not like a ChatGPT 5 in the cloud, but still very powerful. It can recognize not just like faces, like the smart door lock made with 7259. It can unlock someone's face under 200 milliseconds, which that's like 1/5 of a second, which is no time. And then there is like you can interact with the invoice, and then all the information is on the edge. Give a voice command, open the door or like lock the door, or whatever. So this all can happen on the edge instead. And then there's like, for example, health kind of wearables. We can process the sensor information and detect if there's anything that's abnormal, also with models running on the edge.
So it happens right there,
Yeah.
right? Like because sensor data, not only is it sensitive, but it's like time critical. So if you're
Right.
talking about like going off to the cloud,
Right.
you'd lose critical timing on that.
Exactly.
But that's also interesting to think about like the wearable that supports you from like the health perspective. Like I remember my grandparents growing up, they had medications, right? And there's so many of them
Yeah.
at some point, and making sure like you get this many of this and that many of that. The device can see that, recognize it without, going up into the cloud and kind of speak to them naturally instead of some weird like buzzer or something that feels awkward. It now
Yeah.
becomes like an assistant, right?
Yeah. Or even like, for example, the device is detecting your heart rate or your like glucose level, and then it can real time give you feedback of like what's happening. And this can be life saving in some scenarios.
And it's got memory. Hey, maybe you
Yeah.
should go eat that apple and
Right.
get your sugars back up or something.
Very still your apple in the morning.
Right? You talk about your passion project, which is very interesting, right? Like toys, kid safe devices. From a design standpoint, aside from just like processing on device, are there any other features within the boards for enabling kind of like these guardrails or defining certain maybe prompts or things that could be more for safety than anything else?
Yeah, definitely. So I would think about like safety and design from like two perspectives. There's like the hardware component and there's a software component. For hardware component, for anything that interacts with children and humans in general, there's like no sharp edges, no small parts so that they don't choke on it, but still like enables rich interaction. And what we're thinking is like for this toy, because we hear so many parents complain about because like after a long day, they don't have like energy or ideas to interact with their kids, even though they really want to. They end up like iPads or like screens, their phones end up like filling in the gap, which research has shown that this is like quite bad for the children's growth. And so like can we have a more next generation of toys that are very intelligent but still fosters dialogue when your child is like seeking play, and like the education piece can both be fun and also like help the children learn something. So like on the software piece, what we're thinking is we do have like a little screen that helps the children see the picture book. So it acts like an interactive reading engine where with this like little elephant, for example, it will ask questions about the elephant and relate it back to the children's lives. It's like, oh, this elephant has big ears. Do you have big ears? And then also like teaching abstract concepts like this elephant looks sad and then this squirrel is trying to comfort the elephant. And so it talks about feelings so that and describes actions to help boost how they express themselves and how they describe feelings, how they relate to characters in the stories, all through dialogue. So yeah, these are all things that we put into consideration when we're developing this toy. And then we're developing it because I did my PhD at Yale. My advisor actually works on early childhood development. And then when one day when we were talking about what I'm working on now these days, he was like, wow, what if we can make an AI, because they have this training program for like 10 years and it's been like award winning and really shown to improve language ability within a short span of like 4 to 6 weeks. Yeah. So, but like right now, training program is very expensive because parents or caretakers need to spend at least like 3 days in their workshops. And especially for working parents, parents of lower income, they don't have that time to spend like just training how they interact with their children. So, but now like with all the technology, we can make that a possibility. And with the chip, it can enable very low latency natural conversations. And especially with Agora's add-on, low, even lower ultra latency real life conversations that can happen just like when they're talking to their peers.
No, I think that makes a huge difference because a child doesn't really understand the signals going over through a processor and getting analyzed. They're just like, why isn't talking back to me fast enough? But
Right.
when
Exactly.
you're talking about processing on device, offloading minimally to the cloud with ultra low latency deliveries, like that gives it that natural feel, the kind of feel that makes them want to keep interacting in
Yeah,
a way
exactly.
that's not like difficult.
Right.
Right.
Right. And because they want to, like, it will adapt to their kind of interests with the today's like AI models, they can remember what they already learned and what area prompts the most response. So then it will go more into that direction to explore and help them learn even further.
It's really blurring the line on what can be considered like AI enabled. Soon everything's going to be able to be just like powered and enabled by AI in a way that will only help improve us, right?
Yeah, exactly.
So from a developer perspective, I do want to help promote some of the really cool things that not only RiseLink's doing, but we're doing together, right? We said we have the BK7258 dev board. If a developer wants to get started, where should they go? Do they go to your website?
Yeah. Yeah. Well, obviously, I would love to hear from developers. So reach out to us, and then we'll definitely respond. But I think a great place to start will be like from the SDKs and also the developer kit, because, for example, this dev board is ready to be tested if you want it. With the little eyes, it can already serve as like, if you're making a little toy, it can already get you started very quickly. And also, it can be disassembled, and you can just order like the sock itself and then connect it to your audio video, like yourself as well. So we have GitHub online and then also engineers waiting to hear from you. So yeah, I would just start there.
And you mentioned to reach out to you. So you're actively supporting
Yeah,
developers in building physical devices. That's really cool as a company. Can
definitely.
you tell us more about that?
Yeah, definitely. So we are actively supporting local builders and startups that are building all kinds of like really fun things. I just talked to a startup that does Rubik's cube, which they for each little tiny cube, they're making it intelligent, and they have like pictures on it, and then you can play games with it. So instead of the static ones, now everything is electronic, and then like very soon this Rubik cube will have like a personality living inside it and can interact with you. So that's very fun. And like part of the reason I was building the like AI toy is also because I wanted to go through this process of like what are the challenges a developer might face when they're developing on our chips. And yeah, it's been really like just seeing how supportive the team members are. I think also understanding more of the challenges of building in hardware to make sure like how like sometimes you have to pay the first upfront cost. How do you like even to build a prototype on like software now it's so easy to like code up an app and very low cost, but for hardware it's still kind of costly. So how do we help developers support them in achieving their ideas? I think that would be a big topic for us. And we're also talking to high schools, universities to bring up more events so that people can get that hands-on experience developing on the chips with the support from us. There are hackathons that we're planning in the next year so that like students, not only hobbyists who are already engineers in this space, they can get access to like building stuff around their household.
No, you bring up a really good point in terms of like there's a certain investment you need to make just to like kind of get into this world.
Yeah.
And the fact that your team offers something so well put together where the developer doesn't have to sit there and piece together, right? Like from a bunch of Arduinos with separate hardwares, and you got to go find custom chips and things like that. This chip is custom. This is perfect for that developer. Don't even bother trying to do it yourself. Get one of
Yeah.
these, right?
Exactly. Yeah, at the Maker Faire the other day, actually there was a developer that's now developing like a intelligent spider. So you just 3D print the spider and then put our chip inside, and then the spider can talk to you and also like be connected to Wi-Fi, and you can program it to do different like gestures for Halloween. I feel like people's imagination just goes beyond my, what I thought could be possible, and fun little things can all be built now. And we want to support that community growth here.
That's amazing. You've lowered the barrier so much that they're building even like novel household decorations with
Yeah,
AI enabled boards.
right.
It's super cool. And
Exactly.
I love the fact that, dog fooding is so important in this industry. The fact that you're using the chip and going through the developer experience is huge for, your developer community, because that instills that trust. You understand the same pain points that they're having when dealing with it, because that's how software is. Like most people, they have a new idea. It's something first time being applied to this use case. So how do you support and kind of get them over their own hurdles of just like getting their idea across the line?
Yeah, exactly. Especially because building these days requires both the like AI piece, the software piece, for example, like how do we build the AI agent that would interact with you in a way that you desire? How do I choose the model? Like which kind of model do I choose? And then how to optimize my token use. But this is like later down the line. And then coming to the hardware piece, can it perform well in a noisy environment, which I think is like a huge topic for both Agora and RiseLink, because like a lot of the applications are in noisy environments. And then how does it distinguish words that people are saying from like little children is different from like teenagers versus like adults. And then all these like little concerns that you probably like I just didn't think about. before I actually hands-on building this. Yeah, and then like how do you 3D print? What kind of character would you want to 3D print, and how do you lay out the electronics components inside so that the toy can actually hear you when the electronic components are inside its belly, for example. So yeah, there are so many like little details that you wouldn't think about as you're actually building something until you actually build it.
No, you're right. It's one of those things like the deeper you go, the more you learn, and
Right,
it's
exactly.
super cool. So looking ahead, where do you see conversational AI and like hardware kind of evolving to over the next 1 to 3 years, we'll call it? Because 3 to 5 is way too long.
Yeah, yeah. Well, I think it's going to be more and more intertwined. So like in terms of conversational AI and chip design, because conversational AI models, they're advancing really rapidly in quality and decreasing in size as we're optimizing it. On the other hand, chip design for AI is focusing on making it more feasible to run surprisingly powerful models locally so that we like again continue to decrease the latency and then also improve privacy so that nothing can needs to be uploaded to cloud if we don't choose to. I think pretty soon, in a few years, we'll be able to see chips that can run surprisingly powerful models on the edge that will enable much like without having to connect to like cloud LLMs. And then also like something we talked about earlier in our podcast, there's the multimodal AI becoming more popular that can process both visual information and also audio information together. So when we're interacting with our door lock, even we want it to hear naturally and also recognize our faces. When we're building a baby monitor, for example, we want it to take in all these different information and be able to recognize faces and do pattern recognition and all of that. And then building toys similarly. We want to, I guess, the natural interaction, just both visually and also in terms of audio. So I think we're going to see a big advancement in multimodal AI becoming more prevalent as well as our GPU, CPU advance. So that's another direction. I guess one other thing is just since we talked about memory, I think memory is also a huge part and the bandwidth on the chips. So to make it more personalizable and then make it as memory tech is growing very fast, it may be more common that little chips can store a lot of memory information so that your device can truly be personalized and know you specifically.
Adjust over time, learn kind of from your behaviors and learn to support you in the way you need. No, that's super cool. And I'm going to agree with you. The future is multimodal.
Yes.
um,
Because that's how humans interact or are used to interact.
yeah, we are multimodal. We interact on so many different levels, and who knows? One day, these things will probably also have a sensor for touch, right?
Oh, exactly. Like when we're, I guess, talking to the child development experts and also parents, I think for babies, also for adults, I think touch is a very important aspect for things. So, like when the baby touches something, and we recognize it, and then also use that as a source of input to say, for example, the baby touches the elephant's ear, and then we say something about the ear because we know they are intrigued by this. So, yeah, you're absolutely right.
Super cool. Using that as a learning tool, right? Because now screens are touch screen. You can understand where they're applying pressure, what's around them, what's the environment, mood. Yeah, makes sense that
Yeah.
that
Yeah.
multimodal future is going to bring it all together.
Right, right. And that all comes down to like how much processing power you have on the chip and also balancing it with how much power it uses.
This is just the infancy. And if you have this sort of power efficiency at this point, it's going to be awesome to see.
Yeah, I'm excited to have this future together.
So do you think there's going to be a world where like everything has a voice and maybe eyes or the ability to like everything we touch will be interactive?
Yeah, I think that's the future. At least I'm really intrigued by, like the intelligent two wheelers I was talking about. I can't wait to have that actually connected, actually connected intelligence, so it can respond to me via voice instead of like I have to very artificially like scan my app, and then also like type in my address so I can free my hands and actually like interact with all the little everyday objects like a real living thing if we put it that way. And then also like for example, like coffee sensors built in coffee machines to have it tell you when your cup is filled, for example. And also like smart fridges that tell me when my leftover is going bad so that I don't food poison anyone.
No,
Yeah.
no, that's a huge one. It's like, wait, when did I make this? And the fridge could be like, oh, you put this in here on this night.
Yeah. And don't buy more milk because we already have like 3 bottles.
That's the other one, is when you come home and you start putting away the groceries, you're like, oh, I forgot to cross this off.
Yeah, exactly. And they can send you a reminder and be like, get more vegetables because you don't have any left.
It's huge. I've been enjoying this conversation. It's been going so well, but we have blown through our time, and I want to be caught, you know,
Yeah, it was
time.
it was so fun.
It's been a great conversation. I have one question though, and this is
Yes.
kind of our wild card that we ask at the end. If you weren't at RiseLink, what aspect of the AI industry, or what would you be doing? Um, where could you see yourself?
Yeah, I would definitely think more and more the like education space is like AI education space is like really becoming really intriguing. And then also because of like parents' dislike of screens and also it's like actual objectively how it's bad for children, like more fun devices, toys, ways to play for children that doesn't involve like playing with an iPad or an iPhone. I think like the toy industry, we're ready for a revolution. Also, like these days in children's education, how do we help them using like dialogues, conversational AI to help them learn new things? Yeah, I think that's a space that will be very interesting, just like what I'm doing with my passion project.
So you'd still find yourself right in here. There's no other space for you right now.
Exactly. Yes.
That's wrong. Yeah, I love it. Well, thank you so much for your time, and thank you to all our viewers following along. And if you're on socials, do that social thing, like, subscribe, tweet, retweet, reshare, and we'll catch you on the next one.
Thank you.